So we are talking about factoring polynomials, and in this video we will study how to factor polynomials by a method called grouping. And when we talk about grouping, we're usually looking at polynomials that have more than just 2 or 3 terms, usually 4 or 6 or more. So these are already more complicated polynomials. And the idea behind grouping is that we look for terms with common factors and we group them. So that's why it's called grouping. We group those factors. And that's what we're going to do with this following example. And when we do it, we'll actually solve this polynomial. We'll factor it a few times, each time looking at different common factors. So you see that it's a method that you kind of can play around with. So if you haven't seen the other videos about factoring polynomials, they're all in this playlist, and please check them out. And so let's get started. So let's look at this polynomial. We have 4 terms. We start with the third power here, x cubed plus 2x squared plus 7x plus 14. So our polynomial has 4 terms, starting with x cubed, going all the way down to a constant term, 14. That does not depend on the variable. So looking at these terms, we can see that we have all sorts of common factors to the different terms. For instance, this second term here has the number 2 as a coefficient. There's another term here that could have that common factor. That is the 14, right? 14 is just 2 times 7. So let's take these 2 terms and group them together. So we'll write 2x squared plus 14. So we took this term and this term, okay? And then we have to continue with the other 2 terms as well. So we have plus x cubed, so that's right here, plus 7x. So these are our 4 terms. We just changed the order, and we'll even put parentheses to show that we are grouping these terms. What is our next step? Okay, so let's look here. We have the factor 2, and again we said we can remove 2 out of the 14. So using the distributive property, and if you do not remember the distributive property, please check out the video because it's really important for all the factoring problems. So we have from this first group here, 2x squared plus 14, we get 2 times x squared plus 2 times 7, and we put the 2 outside the parentheses. Now we have our second term, and here too it looks like we have a common factor. What is it? Well, here it's a little more confusing. It's not the number 7, obviously, but we can take a common factor x from both the terms inside the parentheses. If we do that, we have x outside the parentheses times x squared, right? That will give us x cubed, x times x squared, plus 7, right? Because the 7 times x here will give us 7x. So we have our 2 terms here, our 2 group terms. And look, inside the parentheses, we actually have the same term. We have x squared plus 7. What can we do with that? Again, we use the distributive property, which is so important here. And we say, let's group 2 and x. We can write this as 2 plus x. Let's put a parentheses, times x squared plus 7. Why is this correct? Well, because we can take 2 times x squared plus 7 plus x times x squared plus 7, right? So by putting 2 and the x in a parentheses with the addition, we basically get the same polynomial, but except now we actually have a factored polynomial. We have a polynomial that is given by a times b, where a equals 2 plus x and b equals x squared plus 7. Okay, so that's one way of doing this. And don't worry if this was quick, because what I'm going to do now is I'm going to just do it all over again, but I'm going to look at different terms. Okay, I'm going to show you how we can do this. Sorry, it was meant to erase that. How we can do this by looking at other factors. So in this case, in this first case, we looked at the factor 2 that was common to 2x squared and 14. Now, let's look at the number 7. Okay, we have 7 here, and we have 14 here. So we know that 14 is just 7 times 2. So let's group those first two terms, 7x plus 14. We'll put them in parentheses because we know we want to group them, plus x cubed plus 2x squared. Okay, again, parentheses. So we basically just rearranged this polynomial in such a way that we have two groups. And in the first group, we termed together the terms that have a factor of 7 in them. So again, using the distributive law or the distributive property, and I'll write it down again because it's so important, we can take 7 out of our parentheses, and instead of writing 7x plus 14, we write 7 times, in parentheses, x plus 2, because we have x times 7 and we have 2 times 7, which is 14. What about our second term? Here, again, we have a common factor, which is x squared. So in the previous example, we had x. Here we have x squared, right? Because we have x to the power of 3, or x cubed. So we have x here. X times x squared will equal x cubed, plus 2, right? 2 times x squared. Okay, and again, we see that by doing this, we have two terms, right? Two groups, and they're formed by a factor times the same group here, right? So again, using the distributive property, we take 7 plus x squared and put them in parentheses, and we say times x plus 2. Because again, we get 7 times x plus 2 plus x squared times x plus 2. And again, we've gotten ourselves the polynomial in a factored form where a equals 7 plus x squared and b equals x plus 2. So that was two ways of doing this. We could start looking at, for instance, the term x cubed and 7x, and in that case, we would remove x. We would write it as x times x squared plus 7, right? Actually, maybe we'll write this in a different color so it's clearer. Okay, so we have, let's just write this over, x times x squared plus 7, and then we have plus 2x squared plus 14. Again, we factor out our 2, so we get x squared plus 7. And we get the same result all over again, where we combine the x and the 2 multiplied by x squared plus 7. So I went through this last path a little more quickly, but basically in all three paths we were doing the same thing. We were looking for two terms that had a common factor, grouping them together, pulling out the common factor, and then looking at the second group and seeing if we can pull out a common factor and whether that ends up with us having a situation where we can factor the polynomial completely. So thanks for joining me. If this was a helpful video, please press that like button. Please check out the other videos in this playlist. They're helpful for all the issues around factoring polynomials.